All right. So I can see Ahmed, Bhanu, Priyansu, Vaibhav, Vivek. So hi everyone. Good morning to you all. And I know in US, it's what time, Ahmed? Right now in the US, it's night, late evening, right? No worry. I will leave you on the mute. So let's continue our session without any further delay. All right. So once again, welcome you all. And on this GuiNet technology, like you guys can get the different platform training. You can see a Cisco Versa, G-Square, Parallel to vPtela, Azure, AWS, Checkpoint, and F5. So any training requirement if you have, you can always contact to us. Now let's start. All right. Yeah, so it's late time for the US. I'm just replying the chat. So you guys, if you feel to reply in the chat, anytime reply, or you can unmute yourself and ask the questions. It's up to you. Whatever you feel, just ask question or reply. It's up to you. So what we are going to discuss today. So yesterday we had a discussion about the benefits of the SD-WAN, why we are going to use the SD-WAN, what are the challenges with the legacy WAN technologies. So now today we'll talk about the component of the SD-WAN and how SD-WAN basically evolved and how what is the idea to just develop the SD-WAN and how it is going to work, right? So when we talk about the normal router, let's say suppose this is our normal router, right? So what is going to happen in this normal router and what SD-WAN router is going to do in the actual production scenario and how it is going to redirect the traffic, how it is going to make the communication from one location to another locations, that we are going to understand. So here you can see this is my one of the router. This is a legacy router, which is Cisco 7604 router. And in this router itself, having the all capabilities, right? They can do the routings, right? You can connect the cables from the input and output, whatever the ports. Let's suppose you want to connect the WAN cable, you can connect here. You want to connect the LAN cable, you can connect here, right? From the LAN, you can connect your switches. So whatever the switches having in your network, you can connect, and from switches, you can connect the end devices, might be the PC, might be the servers, might be your access points and all, right? For WAN, basically it is the ISP connection. So might be your P router is going to be here connected and it is going to connect to the WAN. So in LAN perspective, if any traffic is coming from LAN, it is going to hit the LAN port and the LAN port further going to do something for that particular traffic. And further, if it is required to go to the ISP or the internet, it is going to redirect toward the WAN port. So this is how actual traffic flow is happening in the real production environment. So one port is taking in the traffic, right? So let's suppose this is your, not this is, let me just make a router symbol. Let's suppose this is your router and this router having one of the ports might be gig 0 by 0 and one of the port gig 0 by 1. So this gig 0 by 0, it might be the WAN port, which is connected to ISP, and this is going to connect to the LAN port. This is a switch edge. So if traffic is coming from LAN, it is hitting to this port and further router is going to check some routing on their routing table. And after checking the routing, it is going to redirect the traffic probably based on the destination to this ports. Might be you are going to access the google.com, right? So it will take the google.com destination routes, how it is going to happen, how the DNS is going to resolve. It is based on the DNS record, what are the configure on the end PC, they will change the FPD1 to IP address, and then it will find the Google IP address. Might be it is the 123.10.10.1. So your source is the PC IP address, which is 192.168.10.10. Might be your scenario, it is going to be changed. So this is your source and this is your destination. So once the packet is going to land to the router, it is going to check the routing tables. How actually I can transfer this packet based on the destination information available in the routing table. So once they found the destination routing available, which is telling if you want to go on this particular destination 123.10.10.1, basically you just have to use this ISP link. Then this router is going to process the traffic. So this is the legacy scenario where we are using this particular design where the router is going to do all the routing information. So you can see this router itself having all the component available from where basically we are going to use the routing information. So you can see the same scenario, the LAN is going to take the packet. It is going to punt to the our LAN connected interface. Might be this is a gig 0x1. And then it is going to process the packet based on the control plane module, which is responsible to do the routing information, or they are going to manage the routing tables, which having the rib routing information base, and the fib is the forwarding information base. So rib is basically collection of the all route. Fib is the collection of the best route, right? So rib, whatever the best all possible route you have, they are going to install in the rib routing information base. And further from the rib, they are going to build the fib, that is a forwarding information base, that is a collection of the best route. So if someone asks you what is a rib, what is a fib, so you should know the difference. Rib is the all connection of the route, like whatever the all possible path you have, you just see in your routing table, but the best path that is always installed in the fib, that is a forwarding information base. So my packet is going to be land from the one of the LAN interface. They are going to consult to control plane module, and then they are going to switch the packet to the WAN interface. But you can see in this particular module, we are having the IO modules, that is the input output module. So this is the packets where we are taking the in, that is the input module. And when the packet is going to out, that is known as the output module. So this is called IO module. Basically, you are taking packet in and you are sending packet out. So this is the two modules, that is a control plane module and that is the IO module. They are not directly connected to each other. You can see they are having the blue line boundaries, and these blue lines are not directly connected to each other. Then how their combination is going to happen? How this input packets are going to consult with a routing table which is available in the rib and fib? So this is a question, right? So for that communication, we having the back plane, which is going to connect. Let me just clear this diagram. So you can see, let's suppose the packet is going out via this interface, might be in this direction, and it is coming on this interface, right? This is the input. So my packet is coming from this direction, want to go in this direction, right? So this is the in IO module, but these two modules are not connected. You can see from here, they are not connected to each other. So how they are going to make the connections to each other? They are going to consult their switch fabric, which is basically backplane connections. When you insert the cards, this card, when you insert, they are going to jack in inside the switch fabric. So basically they are going to make an interconnection with the help of the switch fabric. So this card is going to connect in this, and this card is going to connect in this particular switch fabric. And this is going to make a combination of these two. So by the help of the switch fabric, these both cards are going to connect to each other, and then it will become the complete one unit. So your control plane, IO module, and switch fabric is going to connect to each other and then become a one router. So what is going to happen in the next case? The switch fabric will, once the packet is going to come in the IO module, it is going to the switch fabric. Switch fabric basically going to redirect, because they're having the ASICs and physical connectivity behind this, to the IO module. And IO module will check the routing, from which destination the routing want to go. So your packet will build in this way. This having like some source IP address and some destination IP address. So might be the source IP address, you having a 192.168.10.10, destination is 123.10.10.1. This is your Google destination IP address. So that's always routing checks based on the destination. So my router is going to always check the routing based on the switch fabric to the control plane module, and it will going to consult with the rib and fib, right? And rib and fib is going to tell how basically you can go out for particular this destination. So once they will get the instructions, you have to go via this interface out, then they will redirect again to switch fabric, and it will come back again, and it will send the packet via this interface. This is how basically this router is going to work in the our current environment, or you can say the legacy environment. So all planes, whatever decision have to take, it is going to have with a single module that is known as the one of the router or L3 switch, whatever we have. But in SD-WAN, basically it is not going to work in this way. The router will be remain there, but this router will not going to work in this way. So what we are going to do, basically, we are going to decouple this complete box. So they having like one of the open box architecture, one of the closed box architecture, right? So open box architecture, when I talk, that is known as the SD-WAN architecture. So what that means, open box. And if I talk about the closed box architecture, that is known as the legacy WAN architecture. So right now we are discussing the closed box architecture, where all my component, even the control planes, IO modules, and the switch fabric, they all are residing in the one box, and they having this complete visibility about how to process the traffic and all. So this is how basically it is going to be happen. But if I just decouple the things, or my open this box, what I'll do in the SD-WAN, I will say my switch fabric will not part of this box, right? So switch fabric will be removed from this box. I'll say my IO module should be also removed from this box. My control plane should also remove from this box. So I have a 3 modules. I remove all 3 modules. So what is going to happen? My box is going to become open box. So they are not basically inside within the box. There is not something in my house, everything is available. I'm saying my control plane are going to sit somewhere in here. I can say, let's suppose this is my control plane, right? Or I can write control plane. This is my control plane. I'm going to say my data planes might be, which is the IO module, is going to sit somewhere here. So this is a data plane. And I'm going to say, this is my switch fabric. So this is my switch fabric. So this is how my 3 component is going to distribute in the 3 different locations. And once I do these things, that means my architecture become the open box, and this is known as the SD-WAN. But what is the benefits? So let's discuss about the benefits first. So let's say suppose I have 100 of routers. So all routers having their all brains. So this is my R2, R3, right? These are the R4 and R5. And let's suppose this is R100. So you having 100 routers. They are connected with the MPLS cloud, might be this, and this, right? These are the all 100 routers. So let's say suppose you just have to give some instruction to R1. So what do you have to do? You just have to log in. You just have to change the routings, right? And then it is going to take a decision, because their routing is going to update it individually. If you want to update the same routing for the R2, so you probably have to log into the R2 and you have to change the routing destination for the particular prefixes, similar R3, R4, R5, and R100. So every routers, whatever they having a brain, they are dedicated to the box. They are not going to use shared brain. They having a dedicated brain, not shared brain. So that means every routers having their all control decisions, right? And you just have to work with all control, like all control plane modules, which are installed in the every routers. So that is like every changes you want to make, every decision you want to take based on the routings, you just have to consult all of the routers across your fabric, which is a legacy WAN fabric. But what I'll say, if I do one thing, I remove the brains from these routers. Let's say suppose 100 routers I have. So what I'll do, I'll keep one big box. I say, okay, you don't need to take any actions. I'm just putting all brains of the router in my one central locations, right? So you just think these are the brains of the all routers. So this is my big box, right? In this box, I just store the all brains from these routers, right? So these routers become the brainless. So when it's become their brainless, will they able to take the routing decisions? The answer is no, because they don't have brain. So they become the dumb box, like they don't have the brain. So basically they not have to do any kind of the control informations processing. So this is the idea, to remove the all brains from the controller SD-WAN routers, not SD-WAN router, normal MPLS, like whatever the WAN routers, and put in the central locations, then it is going to become the brainless. So these routers have to take any decisions, then they must have to contact to the brain. So this router want to, let's say suppose this router have one PC, right? And this router have another PC connected in the LAN, right? PC2 and PC1. So this router want to talk to this router. So this PC will reach to the gateway, might be the router, and it will try to go to this PC, but it found I don't have any information how to reach to this particular destination because I don't have brain in my locally stored in the my routing, like in my local router. So what they will do, basically they will try to reach to the brain and it going to ask, hey, can you just advise me how basically I can reach to the R2? Then this brain having the complete information about all of the router, they are going to redirect and say, okay, you want to go from R2, then go via this path, whatever the path it is available. So this is the concept. So basically the idea is to remove all of the brains from the routers and put in the central locations, and that location basically known as the controllers in the SD-WAN. So I'll talk what is the controllers, and this is the end devices is known as the IO modules. So this is my IO modules because they don't have the brains. You can see, think these devices doesn't having any brain. See, they have to go on the brain. They just have to consult to the control plane, even within the routers. So same thing I have done. It is the one box router, but I'm saying I have 1,000 of the router, 2,000 of the router, or like I can say 100 of the routers. I'm saying I just have to remove the brain and put in the center locations. And once the brain having any kind of the requirement to reach any social destinations from the any router, any another router point of view, then they consult to the brain and brain will guide you how to reach to the another locations. But who is going to connect this brain and the controllers, right? Again, you can see there is no connection. So who is going to connect? So the connection is going, you can see in this particular diagram, the connection is making the switch fabric, right? This diagram also you can see even within the router, its connection is making by the switch fabric. So again, we require the switch fabric here, but this time this switch fabric is the hardware ASICs, which is inbuilt in the box. But here in our case, this time it is known as the transport. Transport is nothing, it's the ISP link. And this ISP link is the MPLS, internet, 4G, LTE, whatever you think, and broadband. So these are the going to make a connection from controller, which is the brain collection of the brains, and the end devices, which is just acting as an IO module. So probably you can understand this open box architecture in the next slide. So you can see here, this is the same thing. You can see. So what I was talking, again, I have 3 modules. That is a control plane modules. I have another module is a IO module, which is nothing, is the vEdge routers, which is going to install here. And the switch fabric is the same thing, which is acting as my MPLS internet or the whatever the broadband 4G LTE I have. So basically, all the routers in this case of the SD-WAN design, when I talk the open box architecture, they become the brainless. They always get instruction for the routing from the controllers because their brain are sitting in the control plane locations. They don't have individually locally capacity to take a decision. They can take, there are some arrangement they can take, but the idea is they should not take the action by the locally from sitting of the device. They always should consult to the our controllers. But what if a controller goes down? We also having a solution for that one also. Okay, so I'll tell what is the solution for that. If a controller goes down, that means that my routing is going to stop. The answer is no. It will be available, but what is going to stop? What will be available? What is the pros and what is the cons? We having a dedicated module. I'll show you in the lab topology. I'll show you. Let's once we'll ready with our lab. Let me show you where is the lab. So once we'll build our lab, so what I'll do in the lab scenario, every site will be start working. Okay, these all location site will start working. So what I'll do, I'll make this controller goes down, and we'll see even after down going making down this controller, we having the reachability of the sites. But what not going to be make reachable, what the issue is going to be happen, I'll tell that issues as well. Okay, so this is a future classes where we'll discuss about it. Any question, guys, till now? Anyone having any question? If any question having, just try to put in chat one-to-one if you feel, or like group chat, or you can speak up, you can ask anything. I don't have any issue. Okay. All right. So let me move next. So I was talking. Okay, so you can see here also in the OpenWorks architecture, we having the control plane modules, which is just collection of the all devices that having the vManage, vSmart, and the vBond. So we'll discuss all what the device having the what role after this particular explanation of the architecture, and then how basically they are going to connect with the help of the switch fabric and the edge router. So edge router basically in this case of the SD-WAN, when I talk about the open box architecture, they are acting as the IO modules, control plane devices, which is going to extract the routing informations or the brain from the end routers, and they are going to install in the controllers. All the brain are going to install in the controllers. And if let's say suppose they are having one router, this is the edge, and this is the another edge. They want to communicate via this to this way. They always have to go via switch fabric. So this is a switch fabric. From there, they can make a connection. And this switch fabric is nothing. These are the MPLS internet and broadband circuit. So the closed box edge, the where the switch fabric basic, and it is everything inside of the box. And once we decouple the everything, we put the remotely, that's become the SD-WAN architecture. And this is how it is architecture has been defined. So I hope it is clear to everyone what is the closed box architecture, what is the open box architecture, what is the like how this decoupling is going to happen, right? So now I'm moving to just discuss about the component of the SD-WANs, what components we have in the SD-WANs, and what are the different roles and responsibility available in these components, right? So what I'm going to do now, let me just go on the slides. Okay. So if you start definition, if learning of the SD-WAN solution, so I have a like viptela solution like PPT, probably you'll get this PPT and all. So this is the like design, secure extensible network. So why they call the secure extensible network? Because whatever the communication you are start going to do from this particular SD-WAN solution, it's a very secure because they meet the all security parameters. Every security feature is already inbuilt in the box itself. If you want to apply any kind of the URL filtering, DNS security, IPS, IDS, firewall feature, they all will be available. Advanced malware protection, they all will be already available within the box of the any of the vEdge or cEdge routers. So you just have to make the kick to get the connection through the ISP and to the toward the controllers. And once they're having a full connectivity from the ISP toward the controller, they are going to build the again secure control connections between the devices based on the TLS and DTLS connections, right? So I'm using few words, probably I'll make you understand. So I'm just writing here DTLS and TLS. So if I talk about TLS, just think about this is a TCP based tunnels, and it is called transport layer security, which is work on the layer 4. And when I talk about DTLS, that is a datagram transport layer security, and it is always work on the UDP. So these are the TLS and DTLS tunnels, right? So I'll talk more about that where and when it is going to build. But first understand what is my controllers and what is my control plane devices we have, right? So in this scenario, you can see here, we understand in the previous sections, in every architecture SD-WAN, we are just decoupling the inbuilt router solution into a split environment where we putting the controller in one centralized locations. So when I talk about the controllers, it's having a multiple component involved in the controllers, right? So what are those components? You can see here, if I talking about the controllers, in this controllers, we having a multiple component, and these components are known as vManage, vSmart, and vBond, right? So you can see we having the vManagements, we having the orchestration planes, and we having the control planes, right? So again, in overalls, we call a controllers. We call this as a controllers. Even the lab, if I show you here, you can see these all devices which are hosted here, these are known as a controllers. Just forget about the root CA, just focus on these threes. So vManage, vBond, and vSmart, basically these are the controllers, right? But even we are saying in generic word, these are the controllers. We having a further classification and segregation of these devices. right? So it's very important. Overall, in generic, we are saying it's a controllers, but again, we are having a further definition of these devices, right? So what are the definitions? Let's understand those definitions. So you can see in this controllers control plane, we having a further orchestration plane. Again, we having a management plane, and again having a control plane. So if we talk about the controllers, they include all three planes, right? But if you go in the further deeper in classification, we called in control planes, we having a further orchestration plane, management plane, and pure control planes. So why it has been classified? Because the different roles and feature, whatever we define for the control planes devices, based on that, it has been defined as a control planes, management plane, and the our orchestration plane. And what is the data planes? Data plane is nothing, that is our end routers, which is going to serve your actual branch locations. You can see this is the control planes devices, whatever we have, and further we having the orchestration plane, control plane, and the management plane. And they are connecting with a different transport. You can see this is the another connections. They are going to these sites. And similarly, you can see this is device which is connecting to the one of the site. This is known as a data plane device. So it is nothing. It is a vEdge or cEdge devices which is serving you for your company. That is known as a data plane device. I hope it is clear to everyone. Any question, guys? Feel free to ask if you're having any questions. So next, what next? So the next is basically, now we understand what is the control planes device, what is your data plane device. So data plane is your routers. So these are the data planes. Let me just write it. These are the data plane. Data plane is nothing. That is the your routers. This could be the vEdge or cEdge. So might be you confused. What is a vEdge? What is the cEdge? So let me give some better idea. What is a vEdge and what is cEdge? So when I talk about the vEdge, that is known as the viptela edge device, right? When I talk about the cEdge, that is known as the Cisco edge device, right? So earlier this SD-WAN solution was developed by the viptela, right? Later Cisco acquired that. So when viptela developed these solutions, they having their own boxes, right? They're named as the vEdge, Vmanage, vBond, and vSmart. And once Cisco acquire it, it keep the same names. It doesn't change the names, but what they have done, they use their own product also based on the ISR, ASR, and CSR. And based on these routers, they make as a SD-WAN routers as well. So they convert this router in the SD-WAN router. When they convert, these routers become the cEdge router, basically the Cisco SD-WAN routers. And when it was the vEdge, that is viptela SD-WAN router. So these are the router. It could be the viptela router. It could be the Cisco router. It's totally depend which platform you are using. So if I'm using the vEdge router, so let's say suppose this router is the vEdge, right? So this is the viptela router, and this is the cEdge routers. So this is my Cisco router. This is CSR router. So probably I can, let me just stop it and rename it. So you guys having a better understanding. So let me just make as a CH1, right? So now you can see this is my cEdge router. So this is how basically I have a cEdge router, I have a vEdge router, I have the vManage. So these are the viptela. So only Cisco product when we use in the SD-WAN solution, which is going to support, that is known as cEdge, and the viptela one is the vEdge. So I hope it is clear to everyone. Now moving again further. So if I know what is my control plane and data plane, let's further go in the deeper size. What is a further classification of the data plane? Control plane. So in control plane, you can see control plane. Further, we having orchestration plane. It is nothing. The vBond always act as a orchestration plane. So this box, which called the vBond, I am the James Bond. I am the vBond. That is orchestration plane, which having the which is acting as an orchestrator for your fabric. How it is going to do, what is the role, I'm going to talk after this. Okay, so just you make your mind. If I talk about the orchestration plane or orchestrator, that device is known as a vBond, right? If I talk about the management plane, that device is basically known as the vManage. So this is my management plane. So it is a vManage, right? Management plane is a vManage. When I talk about the control plane, that is known as the vSmart, right? So we having a vManage, vSmart, vBond. These are the controllers, but after classification, orchestration plane, it's become the vBond. My management plane become the vManage, and control plane become the vSmart. Last but not least, we having the data plane, which is known as the cEdge or vEdge routers, right? Now, further understanding. I hope it is clear to everyone. Further, we having a classification of data plane. Data plane devices could be the physical device or could be the virtual device. So what is the physical? So you know that in the physical boxes, we having the routers. Let me show you. So these are the physical boxes, like you purchasing the routers, purchasing the switches. So these, when you're going to purchase the router and the switch, they acting as a physical boxes, right? So you can purchase the VS devices as a physical, okay, or it might be you can deploy in the virtual environment. In my case, you can see everything is virtually. My router is virtual, my vEdge is virtual, my PC is virtual. So basically, we are simulating everything in the virtual environment. So if you have in the cloud infrastructure, you want to make everything in the cloud, or might be having a server, and inside of the server, you want to just install the routing or the vEdge or cEdge or any hypervisor, you can do it. So this is like purely data plane device can be deployed in the virtual environment, or might be you can purchase the physical boxes as well. But when you talk about the controllers, these boxes always be the virtual. These are the not physical boxes. So there's just you have to remember these boxes always act as a physical box, virtual box, not as a physical box. So it can be these devices can be always deployed in the cloud environment. You can see it can be deployed in the on premises. It might be hosted in the cloud. You can see here. So these controllers, vBond, vManage, vSmarts, whatever we have, they can deploy in the on premises. How in the on premises? You can buy a server. Inside of the server, you can host the ASXi or KVM, and you can install it. So likewise in my lab also, what we having the Dell server. That is a very high powerful Dell server, high-end Dell server. On this Dell server, basically we having the hypervisor, that is a ESXi, the same thing. And on this ESXi, we deploy all the labs, including the controllers. So this is how my lab is running. So similar thing, if you want to host your controllers in your on-premises or data centers, you can do it. There is no problem. But if you want to host in the cloud environment also, so likewise, last year I have tested this on the GCP cloud as well. So I have taken the free credit of the GCP cloud. I deploy my vBond, vManage, vSmart, and the VS. I created my complete lab as well in the cloud. So this is also possible. You just have to follow the and correct the process, and the should know the correct the approach. Any questions about the deployment? All right. So moving next. So the next is let's understand the functionality of this controller, right? So let me just use the another book. Let me just go this one. Might be they having the very good definitions. So this you see again what I talk about the traditional WAN. So everything like management plane, control plane, and data plane, they are going to stay in the same routers. But if you use the SD-WAN, these all control plane information is going to shift in the centralized location, and that's become the controllers, right? So this is the same thing what I just discussed right now. So this is the same comparison we can see in this document they have done. And once we just go in the more deeper size, you can see this is the orchestration plane, management plane, and control plane. Everything has been defined, and data plane. And these are the further definition of the each elements, right? So let's understand what is the definition of the each elements. So we will start from the orchestration plane, that is known as the vBond, right? So what is the vBond responsibility in my SD-WAN fabric? Let's understand this. So if I talk about the definition of the vBond, you can see here in the vBond, basically, it is acting as an orchestration, control, and the management plane. So what does mean orchestration, control, and management plane? And the next point they're talking, first point of the authentication whitelist model, like, and also they are talking distribute list of the vSmart, vManage all edge router, facilitate NAT transversals, and the highly resilience, the NAT process also they are going to support. So let's understand the layman language, how it is going to work for you, right? So let's think about what is the orchestrations, how authentication is going to be processed. So that means, let's say suppose this is my lab, okay? This is my lab, okay? In this lab, I have the vManage, vBond, vSmart. I build these all device up and working for first time. And this time I want to onboard this vEdge router on this particular fabric. So how the process is going to happen? This device never going to talk to vManage, vSmart first, or any of the vEdge router first. They always have to contact first point of contact as a vBond. If they are failed to contact to vBond, they are never going to talk to any of the devices. They are never going to join the SD-WAN fabric. So the first point contact from the vEdge router should be, or cEdge router should be the vBond. If they are not able to contact, or after even they contact vBond is saying you are not eligible to join the SD-WAN fabric, they cannot join the SD-WAN fabric. So vEdge, vBond is the first point of contact for the any of the device. Even the vManage you are just trying to onboard in the fabric, they will first contact to vBond. Even the vSmart you want to onboard and you want to join this fabric, they have to contact to the vBond. Everyone have to contact to vBond. And if they fail to contact to vBond, and even after contacting they fail to prove I am the right person, they are not going to join the SD-WAN fabric. So you understand in this way. Let's say suppose in your organization you get any, like suppose you are trying to switch your job, right? You having a opportunity to give some interview to some other organizations, and somehow you crack the interview and you are having a joining, might be tomorrow or day after tomorrow. Once you reach to office, what is going to happen? Once you reach the reception, first of all, your HR person will come or your onboarding team will come and they will check your credentials, right? You know your manager's name, might be your team names, you know that because the offer letter might be they have mentioned that, but even you cannot connect them directly. You just have to go with the process. You just have to go with the HR. HR team will ask you to just provide your credentials. You are the right person or wrong person. So you might be have to produce your offer letter. You just have to show your identity based on the national identification number or some permanent account number or some other social security numbers, whatever you have. And once you show them you are the right person, your offer and document is going to validate it. And if they found everything is good, then probably they will introduce your managers. Just think about vManage manager. And then further, he can introduce your all colleagues. Just think about the vSmart from where you can just start your operation, routing, whatever you want to do that. So your vBond is the one point of the contact where you always have to go to prove yourself you are the right person. If you fail to prove, you cannot go further. So I hope you understand that. The same thing they are talking in the my orchestration plane. So this is the orchestration and management plane where they are going to onboard the devices, first point of the authentication, and it is also responsible to distribute list of the vSmart, vManage to all vEdge routers. So let's say suppose this fabric, like in this my network, vBond is responsible to send the all the vSmart, whatever the vManage and vSmart, they having a controller, their information to the vEdge router. So probably they come to know what is my vBond, what is my vManage available in my network, who all are my vSmart, so they can bring the TLS and DTLS connections. So what is the TLS and DTLS connection? How can I check? So probably I can show from here. but probably we go in the deeper size when we build the tunnel, SD-WAN classes from zero. Let's see, today we'll get time, then we can try to have the lab exercise also. So if you run here, so control connections, you can see I have a lot of control connection. They are DTLS connection, could be DTLS, could be TLS. DTLS is always UDP, TLS is always TCP. So here you can see there are different control connection I have. vBond having a 2 control connections with the 2 internet. One is the internet, one is the MPLS. But this is a connect state, this is a down one, but these are the up one, right? But vSmart, vManage all having the up connections because they are successfully authorized and authenticated. But this internet, which internet is not basically failed to authenticate, so they are not able to build the connection to the vManage and the vSmart as well. So these are the connect state. Connect is a down state. Okay, up is the up state. So I'll tell more about how this is going to build the control connections. So basically, the idea is this box, whatever I have, they should basically build the our orchestration plane, authentications, the onboard the devices, they share the list of the available vSmart and the vManage detail to all vEdge routers, and the very important term, they acting as a stern server, right? They acting as a stern server, and it is just facilitate the NAT translation rule as well. If you just wanted to go from private to public network. Okay, so the NAT transversion information, just sending the all the information by the using the stun protocols. They exchange the information from the vBond to the all vEdge routers where they make the entry of the NAT translation, and by using the entry they will try to do the translation when they want to go from the private to public network, right? So this is how highly resilience they can, you can create the 2 vBond in your network, and one vBond as acting as a primary, another will be the secondary. So these all key feature basically performed by the vBond, and this is the role and responsibility for the vBond. Any question, guys, still here? Anyone having any question? No worry. So next, I'm just assuming you all are clear about that. So moving to the next, that is the management plane. So in this management plane, what is going to happen? Just give me 1 minute. Okay, so in this management plane, what is going to happen? This is nothing. This is the vManage. So vManage is a single pane of glass, right? For day 0, day 1, day 2, day 2, 3, whatever the operation you want to do. Without vManage, you can't do anything. So let me just show you the how vManage looks like. Okay. So vManage, if I go in the lab, you can see this is the lab, and you can see this is my vManage. So let me log in and show you how basically vManage, when you just get the access of vManage, what is look like and how basically what all feature you can see inside of the vManage. So here I just log in it, and after logging it, I will go in the browser. So this is my browser. And here I'll try to type the IP address, which is connected in this management interface 192.168.10.1. Okay. So I'll go here. You can see this is my IP address. So this is a ready lab, but from today itself, I'll try to make as a new lab creations. Let's see if I'll get a time. So this is my admin, and the password is also going to be admin. So you just have to put admin. This is the dashboard of the SD-WAN of the vManage. So you can see right now I'm the Cisco vManage dashboard. And once I log into the Cisco vManage SD-WAN, you can see it is showing my Cisco vManage dashboard, and it is looks like the real dashboard. Actually, this is the real dashboard. This is not manipulation. Actual dashboard you can see in the production as well. Nothing is going to be changed. Complete iOS of the SD-WAN we are using here. That is a pure license kind of the all feature available. Even the all licensing, everything is going to work. It's not like we are not going to test any of the features. No, every feature is going to test because we having the license arrangement as well for this labs. Okay. How this licensing is going to happen, I'll tell you the step-by-step process. Okay. So you can see in this dashboard, basically you are login. You can see one of the vSmart available. Didn't discuss the vEdge is 4. That is a data plane device. This is a controllers. vBond is our orchestration plane, and this is my vManage. So this is the dashboard. Whatever you see, this is the vManage dashboard, and you can see it is called a single pane of glass, where I can do the configuration, I can create the policy, I can apply the security, I can make the cloud connectivity, I do the certification, licensing, network design, monitoring, everything, iOS upgradation, event, alarm, whatever you want to do, you can do from this device only. So this is your best friend for the SD-WAN, and you should know each and every tab, how it is going to be used for the vManage. If you don't know how to use the vManage, probably you're never going to good SD-WAN engineer in your life. Okay. So always be like that. You should having the clear visibility about the vManage, and you should know how this vManage is going to be configured, how this vManage is going to be operate, how this vManage is going to play a single pane of glass roles for the day 1, day 0, and day 2 operations, right? So it is called day 0 operation. Why? Because you just have to begin your operation from the vManage itself. So if you want to start your SD-WAN journey, so you just have to start with the day 0 of the vManage configuration. So that's why it's the day 0 operation, or day 2, day 3, and day 4, so on. You can go keep going on, right? Now they're talking about it is acting as a multi-tenant with the wave scale, right? So what is a multi-tenant and what is a single tenant? So let's say suppose you having a vManage, right? So vManage is quite big box, right? And this vManage can be assigned to a single customer, right? Single customer. So that is known as a single tenant, right? But let's say I assign this vManage resources to two customers, customer A and customer B. Then it's called as a multi-tenant. That means you just think about we having a router, right? Router having a one routing table. This router having one of the routing table, and this routing table is known as the global routing table. But when you just split this routing table with the help of the VRF, then it's having, let's suppose you want to make a VRF A and VRF B, then how much routing table available in the routing table? It's a 3. Why 3? One is the customer A, one is the customer B, and one is the global routing table. So it's the 3 routing table we just make in the single router. So basically router is a single physical device, but we just split into 3 parts. One is the global, one is the customer A, one is the customer B, that it has been splitted. Similar in the vManage, we having the resources, whatever the resources I have just split in the multiple part, that is known as a tenant. So I can assign the different like segment or the like section to the different customer, and they are going to completely isolated from one to another. So one customer cannot see another customer information, another customer information cannot see the one customer information. Likewise the VRF, unless you want to just make the rerouting and all, the VRF configuration whatever we have, that is not going to exchange the routing from one VRF to another VRF. So this is the multi-tenant, and I hope you guys understand about this, right? So this is a multi-tenants wave scalable. Centralized provisioning. So all the provisioning configuration, whatever I want to do, that is going to happen from the central locations. That is a vManage. And here I can define the policy, where I can define the template, I can define the routings, whatever I want to do, that I can do from here. And the troubleshooting and monitoring. So I can do all the troubleshooting about the vManage, vSmart, monitor the alert and everything. Software upgradation process, I show you yesterday how the upgradation is going to happen. GUI with the rollback access. So I want to give the roles for different users. Even I can do that. How basically I can do that? You just have to go in the device and setting, and this is the manage users. Right now you can see this is the one user, that is the admin, which having the full access. But we having a different net admin operators, net admin having the full access in this particular section. You can see read write both, but operator having the only the read only access. They can do basic having the some different admissions. If you want to make the new users, you can do it. You just have to add the user. Might be I can add the user as a GuiNet, and I can make as a GuiNet as a username, right? Password I can make anything. And here I can select the user role. I want to make as a net admin. Okay. So this user is going to be created. So we cannot give the upper cases. So always you have to give the lower cases. Let me just take the lower case. I can use this one. So you can see my admin has been created. This is a GuiNet. So if I log out from here, so different roles, different device, different user, I can define the roles here. So if I now I can log in via the GuiNet. So I can log in with my GuiNet and password, not default on admin and admin. So see, it is a login in my dashboard itself. So now I'm logging with the GuiNet. You can see here, this is my username. So this having a feature where I can define the different roles for the different users, and based on the roles, I can if this user having the full access, I want to make the I can do all the configuration from here. And if I want to just give the read and write access or some particular tab access, it is also possible. I'll show you how it is going to be happen in the our modules. So basically, let me show you. So if I'm going here, let me show you the syllabus as well. So you guys at least understand what we are all going to cover. So you can see the exam fees of this particular syllabus, what we are covering here, that is a 300,415 ENSWI exams, right? Implementing Cisco SDWAN solutions. And the exam fees would be the 300 USD plus taxes. So if you want to go and you want to schedule the exam, the duration will be 90 minutes. You can always book the exam, close the completion of the all the topics. So what all information we are going to cover, let me just show you officially. None of the things is going to untouched. So you can see we having a total 6 module here, right? So in this 6 module, we having the architectures, which I'll discuss. So everything from the architecture, I'm going to cover how this control plane, what is the data management plane, what we are discussing right now, management plane, control plane, we just discussing what is the NAT and all. We are discussing theoretical till now, but later we'll do the practical for the everything, how it is going to be configured. Like they are talking about describe. They are not talking about the deployment, but here they are just talking about the theoretically, which we are trying to understand right now, right? So we're just trying to understand theoretical part. Actual deployment come in this particular section 2. So right now we're just trying to understand what are the controller, what is the management, what is the control plane, what is the OMP, what is the vSmart, and then TLOC, IP6, GRE, vRoute, BFD. I'll discuss everything. And then we understand some cloud, what is the SaaS, what is the IaaS, infrastructure as a services and a co-location, everything we'll discuss. Then once we have some good theoretical idea about the SDWAN architecture, then we'll start doing the practical. So no worry, we'll do the mix, because if you go more theoreticals, might be will feel like we are just talking about the theoretical things, so not very interesting. So we'll do the classes mix and match, some theoretical, some practicals. So you guys having the good understanding what we are doing in the theoretical, what we're doing the practical as well. But end goal, everything is going to cover as per the Cisco syllabus. Nothing is going to be untouched. Everything I'm sure I'm going to cover, right? So no need to worry about that. And every syllabus, the policies, router deployment, controller deployment, these all as per the Cisco. So if you guys feel right, none of the any of the topic is missing, let me just know. I'll definitely have like try to make that cover as well. But I'll try my best. Everything should be the cover. So this is my Cisco syllabus, from where you guys always follow which topic has been covered, where we are, right? Next, I was talking about yeah, where it was. So management plans. So software upgradation we can do. We already know how can we do in the vManage. So here we can go and see the software upgrade process. I can do all of the device software upgrade process as well, controller, age, management, whatever I want to do that is absolutely possible. I can do from here. Make sense? And then the GUI rollback we discussed, REST-conf, the programmatic interfaces, REST API, netconf, that is also possible for third-party integration. If you want to access the devices from the APIs to integrate them with the REST-conf and netconf, that is also possible. High resilience, we can make the two vManage in the resilience HA format. So one is the active as a active, one is the primary, one goes down, another will take a role. So this is also possible. So I hope this management plane and the orchestration plane is clear to everyone. If you guys having any question, you can try to make your question on YouTube live as well, or you want to ask on the Zoom, you can ask on Zoom or unmute yourself and ask as well. So moving next, that is my very important plane. That is my control plane, right? So what is a control plane? So we understand about the orchestrations, we understand about the management, the control plane having the box which is known as the vSmart. So vSmart controller is basically acting as a controller, which is having the full control on the routing and policies, whatever you are building for the SD-WAN fabric. So whatever the routing policies you are building, that is going to happen on the SD-WAN fabric based on the SDN controllers, right? So it's facilitate the fabric discovery based on the routing. So it will help to discover your fabric for the different location. Yet it is going to form the OMP session and they're going to exchange the routings and also dissimulate the control plane information between the edges. So whatever the control plane information I want to exchange between the router, it is going to happen with the help of the routing and help of the policies. Distribute data plane and app aware routing policies to the vEdge routers, routing policies, everything it is going to give to the edge routers. Implement the control plane policies such as a service chaining, multi-topology, and multi-hop. So we'll discuss what is the service chaining, what is the policy, what is the localized policy, what is the centralized policy, how it is going to exchange from the vSmart to vEdge router in the upcoming sections. But for now, you just have to understand they having a responsibility, basically policy and service chaining, whatever you have, just by the help of this vSmart controller, it is going to be exchanged between the devices. Additionally, it is going to reduce the control plane complexity because it is going to form simple OMP connection between all the locations. And if one location want to talk to another location, they just have to connect to the control plane. And this is going to give the instructions because this is the brain which having the complete routing informations. And based on that brain, they are going to come to know how to reach from one location to another locations. So this brain is going to give you the complete visibility without making any complexity like with the legacy routing scenario, right? So this is how it is going to make a control connections. So this is all, it can be also deployed in the highly regimenous form as well. So I hope you guys understand about the how the controller is going to be happen. Any question, guys? So we understand about the controllers, we understand about the management plane, orchestration plane, and the control plane. Now this is the last one, which is known as our data plane. So without this data plane, we cannot connect our branch locations. So this data plane is also very important. And you just have to basically use to connect this data plane to the all branch locations. So whatever the branch location I have, you can see here, a lot of branch location I have. And these branch locations basically have to connect with the data plane. So how basically I can do that? Let's understand. So where I was, okay, so this is the data plane. So Vmanage device location, whatever the vEdge or cEdge router we having, they acting as a data plane, and this can be deployed in the physical and the virtual environment, which I already explained to you all, right? And provide a secure data plane with the remote edge routers. Wow. So what that mean? So that means they provide the secure data plane. So what is a secure data plane? So what basically they do, once you build the SD-WAN fabric, let's say suppose these two sites want to talk to each other, right? So how basically they will talk? They cannot directly talk to each other first. They just get the routing information first from the vSmart. So they both will get the routing information from the vSmart, and they will form the OMP connection from here to here, right? These are the OMP connections. So let me just write it. So these are the OMP connections. So based on the OMP connections, like OMP sessions, OMP is the overlay management protocols. Let me just write it. Overlay MGMT protocol. So this is my overlay management protocols. This is a Cisco proprietary overlay management protocol. So this is build the OMP session, and based on the OMP, they will exchange the routings. So once vSmart will tell routing information of the VH4 to the VH3. So VH3 will come to know the TLOC informations. What is a TLOC? So transport locator. So TLOC is a transport locator. Let me just write here. Transport locator. So this is a TLOC. It having a 3 tuples. Might be discussed later in detail, but writing here, TLOC having a 3 tuples. That means the 3 component they having. One is the system IP. Another is the encapsulation. And third one is the color. So we'll discuss more. What is the system IP? What is the encapsulation? What is the color? But just think, if I talk about TLOC, that is a transport locator. So if this router want to reach to this particular router, so they just have to know the TLOC information. That means they should know what is the system IP of this particular VH4, what is the encapsulation, what is the colors. And based on that, they will try to reach from site 3 to site 4. But to reach this, they will form a secure fabric here, and based on this secure fabric is known as the IPsec tunnel. So they will form the IPsec tunnel automatically, and from this IPsec tunnel they will exchange the all data information from one site to another site. So the routing will be exchanged from vSmart to vEdge routers, and based on the routing information, basically they are going to make connections between the sites between the VH3 and VH4, and from that they build the IPsec tunnel, which is highly secure, and from there actual data is going to be communicated from this site to this site in this way. So this is the same thing they are talking in the PPT. They are talking basically here is Vmanage router provide the secure data plane with the remote edge router, establish the secure plane OMP, like this is what. And after this, establish the secure plane data vSmart controller. So this router is going to build the vSmart OMP stations for different routers. And this OMP session basically going to exchange the routing information from this one router to another router, right? And implement the data plane application aware routing and policy, and export the performance statistics. So how my LAN is performing, what is my WAN is performing, the every statistics is going to be captured in the vEdge routers, and it is going to populate it in the vManage routers, right? So this is how it is going to build, right? And after, they can leverage the traditional routing protocols like OSPF, BGP, and VRRP. And also, let's suppose in the LAN you're using the OSPF, BGP, and VRRP, it is going to be basically connect. Like let's say suppose this is my LAN, this is my LAN, or this is LAN having the BGP OSPF running. So this can be also integrated by the help of the BGP OSPF and EIGRP. So this protocol also can be supported. So let me just see. Lokesh is asking on YouTube, how can I join, sir? So Lokesh, just give me 1 minute. Let me share to the Zoom link with you. You can join. Just give me 1 minute. Probably I can share the Zoom link. Let me see if I can share here in the YouTube link. So Lokesh, I have shared the Zoom link. If you want to join, you can join it. No problem. Okay. All right. So you can see, guys, this particular all the features, whatever I have, I'm talking. The Vmanage routers, that is the data plane device, provide the secure data plane with the remote edge routers for the building the IPsec tunnel where the data can be exchanged. Establish secure OMP plane, OMP tunnel with the vSmart. So how basically it is going to be secure? Let's understand this one also. Basically, before establishing the OMP session between the vEdge router to vSmart, they just have to form the TLS and DTLS connection, TLS or DTLS connection. And over that TLS, DTLS connection, they are going to form the OMP session. Let me show you, might be somewhere I'll find it. So not this one. Let me just see this one. Let me show you how basically it is going to do that. So this is my OMP session. This is my, you can see here. So this is my vEdge router one. You can see in this vEdge routers, they just have to build the OMP session with the vSmart controller, and vSmart controller again build the vEdge router. So this is going to build under the TLS and DTLS tunnels. So they first build the TLS and DTLS tunnels, right? And after building the TLS and DTLS tunnel, they are just going to build inside the DTLS and TLS OMP sessions, right? So OMP session is known as the overlay management protocols, right? And then after going on the overlay management protocols, they basically build the OMP table where the policy and routing going to be exchanged to each other. And this is basically the green. When everything is going to be established, they exchange the TLOC information from the vEdge to vSmart, and it is going to populate to the vEdge routers. They are going to form the IPsec tunnel. And this is the green one, IPsec tunnel. Inside of the IPsec tunnel, they form the BFD tunnel. So I'll make you understand what is the BFD and what is IPsec tunnel in later stage. When I'll start the configuration, I'll show you how the BFD is going to form and how the
OMP session is known as the overlay management protocols, right?
Hi, Lokesh.
And after yeah, hi
Lokesh.
sir.
Hi. Hello. All right. So hope you understand, right? You have seen the video on the YouTube, right?
Yeah.
Okay. Makes sense. No problem. So we were discussing here about the whatever, yes, IPsec tunnels and the DTLS and TLS tunnels, right? So this is going to form between the edge devices, that is IPsec and BFD. So first IPsec build, and then inside of the IPsec BFD. Many of the interview might be it is going to ask which tunnel is going to be formed first, and then which is going to come second. So you can see here DTLS TLS build first, then under the DTLS TLS your OMP session is going to be formed, right? Similarly, IPsec tunnel first, build first, then the BFD tunnel is going to be first, right? Second. So this is how the IPsec BFD is going to be formed. The next one, like what I was trying to discuss. So this is the implement data and application aware routing and policy. So whatever data plane and the application aware routing, that is known as the AAR policy, it is going to be implement from the directly from vManage to the vEdge routers by using the netcount protocols. And this is going to be act when the data policies is coming to whenever data traffic is coming to just go out or in based on data policy, it is going to be implement on those particular traffics. Application aware routing, basically based on the application you want to do routings, then it is going to be play a very vital role while sending one traffic, one link versus another link, right? It is going to also export the all the performance statistics. That means how my LAN is behaving, what is my WAN is behaving. Based on that, they are going to set your all the performance and all the statistics, and that is going to send to the vManage, and vManage is going to get all logs information. So you can see yesterday I told you, like if you're going any of the devices, let me show you. This is my dashboard, and if I want to go on any of the devices and real time, so all the statistics whatever device is having, like interface uses, applications, top talkers, you can see this is showing what is the utilization real time. If you want to export for 7 days, 2 days, 1 day, it is always possible for you. TLOC information, tunnel information. So everything you can export from the any of the router point of view, and it is absolutely available. I told like it is going to leverage the traditional routing protocols. You want to integrate with the BGP, OSP, or VRRP. It is going to support it by the SDWAN fabric. Zero touch deployment, zero trust, zero touch. I discussed yesterday. So if you guys are not aware, what is that? I'll share the video for that. And it is also going to support the physical and virtual factor. No worry, zero touch provisioning. We having a dedicated class, dedicated module. Let me show you. So when I little bit go some classes, I'll explain what is the ZTP process. Okay. So I'll completely tell you how this ZTP process is going to work. So all the steps I'll explain about the very detail about the ZTP process. So no need to worry about that for that also. And it is going to deploy in the physical and virtual environment factors. So that is also possible. So I hope we understand at least functionality of this particular viptela for the control plane and data planes, right? All controller functionality we understand, right? So next thing, what I'm going to do, I say like there is a lot of theoretical things I covered today. So what I suggest, you guys just have to go with this video, try to understand about the functionality or digest about this controller behavior, what that means, the orchestration plane, data plane, management plane. Then in the next class, I'll explaining more about the labs, right? So what I'll do, we already having the idea about the controllers. So from next class onward, we purely like what I'll do, you can see, let me show you. So this lab is fully ready, but I'll start configuring the labs and I'll make all controller up and working in the next class. Okay. So we'll make the controller up and working. We'll make the IP connectivity, how they are going to be configured, what is the role of the root CA, how they are going to authenticate, how the certification is going to happen. Because this lab is fully configured, but I built the new lab for the August batch, so which is already started. This is day 1. So if you guys want to register yourself, you can always try to reach out to us. We'll make the registration because this is a day 1 class and recording will be also available. So this is the lab I just prepared for you all, right? This lab has nothing configuration. Okay. So what I'll do, I'll just start configuring from this PC, from this vManage, this switch, this vBond, this vSmart and root C. So this is the first task we'll do in the next class. And in this next class, we'll build the controller, which is the very toughest work in the SD-WAN. But no worry, for that, what I have done, I already prepared the lab guide for you all, right? So let me show you. I have already lab guide created for you all, where you can get step by step all the informations. So let me just see. What is the lab? Yeah, this is lab guide. So here you can see this is the all lab guides, like how basically we are going to onboard the vManage. So step by step, every step is written here. So you just guide once I'll give the lab access, you just guys have to follow the steps. Every step is written how basically it is going to happen, how basically certification is going to happen, how the lab is going to build. So everything is written here for the vManage point of view. Similarly, I have just prepared for you how the vSmart configuration is going to happen, how the certification is going to happen for the vSmart as well. So this is also available. Similarly, after vSmart, vManage, we just have to onboard the vBond also. So vBond configuration steps, everything is written here. So I'll share this all information to you all, right? Once you the new person who not completed the registrations, they don't have the lab guide and the lab credential yet. So try to contact the support team. They will help you to create your lab credentials and also help you to, if you are trying to join the live session, just call us. They will definitely help you to join the live session. The lab will be 24/7 available and you will get your own credentials. You can try to play around the labs, uninterrupted lab. There would be not any issue. So this is also one of the good things with the GuiNet technology you can always use. So this is the vBond configurations. And similarly for the vEdge configurations, how it is going to first time build, you can see here, vEdge is also like ready here. So all vEdge features, how it is going to be configured, how it is going to build, that is also ready. And we having the very good things for the cEdge as well. So you can say cEdge configuration lab, guys. Even I'm sure I just keep the promise to everyone. I'll even tell you how the CSR cEdge is going to be onboarded in this particular lab. So let me just stop it, make the name again the cEdge. So this lab cEdge also available. So this is my cEdge one. So I'll make this cEdge also up and working. So this cEdge also. So cEdge lab guide is also step by step, all the configuration for the cEdge also available. You can see how it is going to be onboarded in cEdge, what configuration we have to do. So this is a unique things you will get, because the every classes, every like institute will find the only the vEdge onboarding, but I'll show you from the cEdge also, and I'll show you how it's cEdge going to be onboarded, how they are going to configure, because cEdge having a different set of the configurations in compared to the vEdge, and might be in your environment you'll find the cEdge as well. So this is also going to be happen, right? All right, so what next? After this configuration, we will have this every whatever the labs we are going to do, every lab guide is also available, how the DIA setup, extranet, hub and spoke routing policy, root CA lab guide. So everything is QS policy. So almost every lab guide is available. So you will get these all lab information. No need to worry about that. Okay, guys. So any question till now here, because the next class I'll make a very interesting to just how to build the labs, because these boxes are not any configuration. I'm not going to start, because if I start, it will ask some process to do that. I'm just stopping it. But let me show you the vBond. vBond, even it is no information. So vManage, I'll show you how it is going to be do from very scratch. So you can see this is the default configuration. Show run. So you can see there's nothing is available. No configuration is also available here. Just give me 1 second, guys. So this is how basically my vBond configuration root CA, when no configuration is available, right? So this is no root CA configuration also available here. So this is my promise. In next class, we'll start very interesting. So I hope you all okay, guys. So let's continue this session from the next class. So I'm going to stop it here, because if I start doing this lab configuration for time being, it is going to take more time. And I don't want to push a lot of theoretical things in the day one. So you guys having a lot of confusion. So I would suggest just go with the recordings. Already it is going to upload in I'll give the recording access to everyone. That's video by the end of the day. So try to complete your recordings. And if you're having any question, try to put in the WhatsApp group if you have any questions, right? And after that, probably we can go for the lab configuration. So one of the person is asking on the YouTube, sir, what are the images are you using? So for the images, may I know your name? Can you just put your name? I can see your name is a network security on the YouTube channel. So definitely you can build it in your home lab. So may I know your name, please? I can see it is showing in the network security. So what is your name? I can tell the labs. Let me show you. No need to worry. It's having the very latest image, guys. In our SDWAN fabric, you can see this is my, if I, you can see viptela 19.2.3. So this is the latest one. After that, we're having a 20 series of the images. So this is even the latest image. Most of the institute will find it is running on the 18 series, which is quite old, which not supporting a lot of feature, but I'm using the latest one for the lab perspective. So this is already available. All the controllers, whatever I have, they are on the latest image, right? No worry, network security on the GuiNet, just call us. We'll definitely help you out, okay? Just call us on the given number. We'll definitely help out to you. All right. Thank you so much, guys. So bye bye. Have a great day ahead. We'll connect in the next session. Okay.